the company called Linux Networks. Commercial support is done by SCADMD at the moment, and they're the main developer of Slurm, and it's a quite active community just because of how many sites have adapted Slurm. And there is a relatively active contribution going on. So basic features. I come from Grid Engine, and I find that worth mentioning. For some people in the audience, there could be standard Slurm is topology work. So that means if you say, I want to schedule on a socket, I want to have one process running on the socket, and I want the process to use 4 threads, you can do that by default out of the box with minimal configuration. It can do task socket core thread. It can do topology work scheduling in the sense that if you have, let's say, a torus, you can tell it how your topology looks like, and it will take that into account. It has CPU support built in, so you can constrain CPU, memory, swap, kernel memory, and devices like GPUs without constantly polling for the usage. I would say it's administrator friendly up to a point. You have a single configuration file, and there is really, really extensive documentation. It's highly scalable, as already mentioned, and the other thing is it's extremely configurable. You can do everything with Slurm, which is good and bad sometimes. So how the architecture looks like, very standard. I'd say you have a controller, and the controller has a failover pair. You have a DBD, a database daemon, which sits in between Slurm and a database, which does some caching and that kind of stuff. And you have a Slurm D that runs on the compute nodes, and the Slurm D talks to the compute nodes using a hierarchical fan-out scheme. So what you can use them for example is not only the RPCs that Slurm does to talk to its nodes, you can also broadcast binaries over the transport, which could be interesting for, let's say, a Cray machine where your binary is statically linked and you don't want to hammer the parallel file system. You can just do srun -- pcast, and it's going to push it over the Slurm RPC transport. I mentioned you have no single point of failure. The database needs to be MySQL nowadays, or Percona or MariaDB, basically MySQL compatible. There was a Postgres support in the past, but I think that's unmaintained now. I think we're going to go over the basic concepts here. There could be so I guess the audience already knows that, but I'm still going to do it. So jobs and job steps. Learn us the concept of not only you have a job, but the job contains several steps. So every time you execute a process in a job, it's going to be tracked as a separate step. And each job step can use a subset of the allocation. So if you allocate, let's say, 100 nodes, and you do an srun, you can do the srun on 10 nodes, and you can partition your big allocation into smaller ones if you want. Does that make sense? If you have questions, just ask right away.
So that means you can only use the smart part of the allocation, and then that small part can be used by other jobs?
So if you do an allocation, like you do an salloc in Slurm, it gives you what you requested, and then inside you can do like fine-grained. So you can say, okay, I would like to run a process on every socket, for example, but only on the first 2 sockets for whatever reason. Maybe you need more I/O. And then in the next, so inside an salloc block, you can basically do sruns, and those are executed in the allocation that Slurm gives you.
People lock on all the resources.
Yes.
Yeah, okay.
But also like dynamic, like you have you request, let's say 10 cores, and you have 100 jobs you want to run. You can say just run them, and if one's done, run the next one. Like you do with Scoop or something like that.
I think you could, yes. So if you just put sruns in a row, they're gonna block if you not have resources available. I think. I will need to try that. Partitions. So usually you talk about queues. I think the equivalent in Slurm would be a partition, which is basically a logical grouping of nodes, and those can be overlapping. So you can have, I don't know, an interactive partition overlapping with a regular one. And you can apply limits on that partition. So that's pretty standard. You can say, on this partition, I want default 6 gigabytes of memory per CPU that's allocated, or I want, let's say, for a non-MPI partition, you can say I want maximum 1 nodes that can be scheduled, and etc. etc. Basically everything that Slurm allows, which is a lot. Then there is quality of service, which controls the scheduling priority of a job. So if the job gets into the queue and you define the queue as that's, let's say, high priority, it gets into the queue at a high priority level. That's one of the factors it influences. Another one is it affects preemption. You can say a queue as real time, for example, those jobs cannot be preempted. And an interesting use case is you can, as I said, enforce limits for a job, but you can also attach the quality of service onto a partition, which enables some really funky stuff. Like you could say, my partition is the whole cluster, and the QoS on the partition is, let's say, 150 nodes, and then you have basically a floating partition that if you have several QoSs, they're going to float, and they're going to take the nodes as they get them from the whole of the machine. Point I find worth mentioning is there is the deny on limit option, which means if you set a limit on a QoS or a partition, Slurm by default is going to submit the job, and it's going to sit there and it's going to say, well, I'm waiting for resources and they're never going to come. And the non-default behavior is deny on limit, which means if you submit something to QoS that doesn't have the resources, it's going to throw the job back at you. That's usually what users expect, I'd say. It's a then catch. Slurm knows about resources, so not only CPU and memory, also GPUs, mix, like Intel KNLs, energy, so you can do energy-aware scheduling, and all of those resources are implemented as plugins. That's an interesting fact about Slurm. Basically everything is implemented as a plugin, so you can extend.
Where's the battery there? Check the battery. It is.
I'm just gonna scream.
I can hear you fine without the coffee maker.
Without the...
We can hear you now that the coffee maker's not running.
Alright, so that's fine. And you can track the resources. If you say I want to track GPUs, you can enforce limit on the GPUs. Let's say a job can only use 1 GPU. And also noteworthy is that Slurm can do billing by default, so you can bill for GPUs, for example. Or you can bill for CPU and memory. So if you reserve a node using 1 CPU and all the memory, you can bill for the whole node, that kind of stuff. Examples for trackable resources would be, well, as already listed, burst buffers is an interesting one, generic resources, licenses, and nodes as a whole. Scheduling, that's the main part why we use a scheduler, so that's pretty important. Slurm by default does a 2-stage approach, I'd say. So if you submit a job, it's gonna quickly try to schedule the job and it's gonna see if it can run. If it can't, it's gonna just sit there in the queue, and if it can, it's gonna execute instantly. I think that behavior can be turned off. So if you run a excessively high throughput cluster and that's detrimental to you, can turn the behavior off, and then you only get basically backfill or FIFO or whatever you like. This fast scheduling happens not only on job submission but also on job completion and on configuration changes. After this first stage of scheduling passes, the main scheduling loop starts to run, which is, I mean, you can do FIFO and backfill. I guess everybody is going to do backfill. And backfill itself is highly configurable in Slurm. So you can very finely tune the scheduler for your workload in particular. I'm going to show an example of how we do the NERSC, but you can, by tuning parameters of the backfill scheduler, say, well, how deep do I go in the queue, how many jobs I test, how long is the time window I want to look into the future, maybe I only want to backfill, let's say, 10 jobs per user. That's all possible using Slurm. So another thing I already touched upon a bit is priority, because your queue is going to have priorities for the users. By default, that's FIFO. Not recommended. There is a multi-factor priority plugin, and this is how the job priority is calculated. And every parameter in there is tweakable by the system administrator. So basically you can you can try to reflect how you want your machine to be used. And as we see here, age is factored in, fair share is factored in. If you want to job size, partition, constraints, the quality of service, and that's usually turned off, I guess, but you can, the TRES are the trackable resources, and you can factor those in as well, if you'd like. The way we do that at NERSC is a bit special, I would say, because we don't do fair share. Everything's basically done by age. So if your job ages, it goes up in the queue, and basically the entry level is determined by the QoS. So we have different QoSs like scavenger. Scavenger is when you're out of allocation, just jobs that run for backfilling. That's the lowest priority, which starts somewhere with a 0. There is no effect by the QoS. Then it gets to regular, which is the normal. So if you have allocation, and then if you need more, you can get premium, or if you really want to spend your allocation quickly, you can get real time, which gives you very quick turnaround, puts you basically at the head of the queue, but it costs a lot. The reason why we do not do fair share is that if you do fair share, you constantly reorder the queue by priorities. So depends on how many jobs run per user, you're going to start reordering the queue. And the way that Slurm does backfill, and that's something you can read in the documentation because that's a longer explanation. This is detrimental to utilization in the case of NERSC, I have to say. So, for example, we don't consider jobs under a certain priority for what Slurm calls reservations. They're basically only considered for backfill. And in the use case that NERSC has, which is run very large jobs with, I don't know, 6, 7, 8,000 nodes at the same time, and very, very many smaller jobs, that actually increases throughput and utilization a lot, up to the point. So what I've heard, I don't know if that's true for everybody, but usually if you have a big job run with, let's say, 8,000 nodes, your consultants are gonna do some hand-holding with the job and put in a reservation and see that the job executes in time. NERSC does 6,000 to 7,000 node jobs without any problem and without much hand-holding. And now, so that was like the basic stuff what a scheduler should do, and I'm gonna get to the more advanced features which have been added to Slurm recently, also with regards to more data-intensive processing. Like burst buffers is a famous example, container integration, the Job Submit plugin, that's an interesting one. The newer versions of Slurm can also do federation, and I'm gonna go a bit into what a SPANK plugin is. So, burst buffers were a thing that was developed by Cray to basically support applications that need lots and lots and lots of I/O. So the way that's realized is they put flash into the machine and then provision the flash dynamically, in a nutshell. So Slurm supports that, so you can request an allocation inside your scheduler and you can say, please stage in the data into this allocation and stage it out when you're done with the job. And that's, so at NERSC that happens at the moment because Slurm talks to the data warp APIs, but this, the plugin that does that has a generic function where you can basically put in shell scripts, which means you can hook up a shell script to the job and provision whatever storage you want. I think BGFS can do like BGFS on demand. That would be an interesting thing to do. I don't think it's very readable, but I have an example down there.
Where does the script run? Is it on the scheduler master node, or is it?
Ah, that's a good question. In this case, it runs on the data warp nodes, so they do the staging.
And
So
in the generic plugin case?
that's wherever you want to. I see what you're saying. That would be the controller. So the controller would execute the script. I'm guessing, but I think that's very close to the truth.
Does it drain data as well? What does it do about, so once the job is done, if you requested a burst buffer, can you drain it after the job is over?
So there are two kinds of burst. Drain in the sense of staging out.
Yeah.
Yeah, you can do that. So I think that's not very readable, sadly. But those are directives you put into your job script, and BB is for burst buffer and DW is data warp. So the first line sets up. There is a very interesting thing here that the Slurm commands are called BB and the create commands are called data warp, like DW, which personally it makes me incredibly nervous, but that's just the way it is. So BB create persistent creates a persistent data warp reservation that lives long, like over the lifetime of a job. And the second line is a job-based data warp that gets destroyed after the job finishes running. So that's an interesting use case for, I think we have some genomics group that take I think a BLAST database, put it into a persistent reservation, and the jobs they run use the BLAST database inside the burst buffer and not on Lustre, because Lustre really doesn't like that, to put it kindly. Container integration is realized as a SPANK plugin, and who would have guessed, as it's developed at NERSC, Shifter is integrated with Slurm. There is also a Singularity plugin that does the same thing since, I think, September last year. Example command line would be, you allocate a job and you want the job to run in your custom full stack pipeline image that you have gathered over the last 15 years, and you will mount the project directory into global project. So basically a bind mount. Those are quite equivalent to Docker.
So I can actually just say Docker, TensorFlow, latest, my volume, this is my script run, that runs nicely in the Singularity container.
And then it runs under no optimization, so.
Yeah, of course. Yeah, of course. So still pretty cool.
I heard there's going to be a talk on Sunday at FOSDEM about that.
Yeah.
Yeah, and if it runs for good reason, it doesn't really make that much difference.
As somebody working at NERSC, I can tell you, don't use Singularity. Shifter has some interesting features for HPC centers because it has an image gateway that can manipulate the image in the way you want before it gets to the cluster. That's an interesting thing.
Oh, actually, yeah. So
Yes.
Do you have, well, you know, do you guys run this on GPU clusters?
CSCS does, I think.
But then to run the TensorFlow image with GPUs, you need NVIDIA Docker, right? It's special.
It's exactly done.
You don't? Okay.
I love that
You
you
can actually give it an option and it will pass the system libraries through.
Does Shifter support the GPUs?
yes,
Okay.
but it does not through. I can actually answer that question. Lib NVIDIA dash container, as it's called on GitHub, it
Yeah.
doesn't use that. Which, I mean, in the end, all that thing does is basically bind mount libraries into the container. Like everybody else, once you, I mean, I'm starting to ramble here, but once you start pushing libraries from your host into the container, stuff gets hairy pretty quickly. So the silver bullet thing is really, who would have thought? It isn't. Just depends on what you're trying to do. So yes, containers are supported, not in the way Docker does though. In the sense of you can use network overlays and that kind of stuff. Then there is a pretty cool thing, cool or scary, depends on what your sentiment is in regards to very thin APIs that can access internals of Slurm. But a Lua Job Submit plugin means that every time you submit a job, a Lua script runs, and that Lua scripts can modify the parameters of that job on the fly. Depends on some logic, business logic in general, is what you would put there. This is incredibly powerful. You can literally access scheduler data structures in the Job Submit plugin. I wouldn't recommend it, but you can. And Doug Jacobson used that to implement a policy engine in Lua that runs on every Job Submit plugin. As I asked if it can be open sourced, he said yes, so I volunteered to do the paperwork, so you can expect an open source publishing of this policy engine in the near future. But you can basically say, so the way it works as NERSC is the only thing that the user specifies now is QoS. So he says, I want to run normal priority, high priority, or real time, and everything else is done by this policy engine when he submits the job. So it looks at the runtime of the job or how many nodes it uses and puts it into the red partition for that. Yes?
Oh, I just had a comment on the Lua Submit plugin. This is something that we're using extensively at computational. So, if you guys have any questions, I could probably look them up for you. But because some of you may be using routing queues using Torque at the moment, and Slurm doesn't do that by itself, but it can do the equivalent thing using a Lua Job Submit plugin. The only thing that I think was missing, that this Lua plugin could not access the number of tasks in a job. If you just say, I want a job with 72 tasks, and I don't care where it ends up, then that number was not accessible, but that was fixed in a more recent release.
It's how do I say this? It's a very arcane API kind of in the Job Submit. It doesn't do much abstraction in the way that, so basically you see how Slurm handles the jobs internally, which means you need to understand how Slurm handles the jobs internally to actually use it to the fullest extent. But as you mentioned, routing queues would be an interesting use case, because the way that billing works at NERSC, so billing and accounting is done by what we call NIM for NERSC Information Management, I think. So that's not done by Slurm itself. So the checks, if you actually have enough allocation, are also done through this Job Submit plugin with the Redis cache in the background. So you can do all kinds of stuff in there. It's incredibly powerful. I think it needs a very high level. You need to be very careful in using this. It can get out of hand pretty quick.
This is only, users cannot access it, right?
No. No, well, in our case, at the administrator, we have like a Slurm team, the scheduler team.
Yeah, but I mean, as an end user that submits jobs, they can access it, right? I hope.
That's the case. Yes, but I think if you have very sophisticated users,
No, it runs on the scheduler, right? The script, it's not on the client side.
yeah, that's true.
You cannot just bypass.
You can bypass it.
No, you can't. No.
I think there is a way to bypass it if you mess.
Yeah.
I think if you mess around with the Slurm libraries, like dynamic linking, then you could bypass the Job Submit plugin, I think. So there, but you need really, really sophisticated users for that. I remember talking about this, and I think that was the.
We had another example plugin is to restrict access to worker nodes. By default it doesn't, but you need to enable a plugin that integrates with SPANK so that you want to...
Next slide.
Huh? Sorry? Next slide? Okay.
That's a really cool plugin.
Yeah.
It's the... Right. So Slurm in the recent release, I think 17.11, it can do federation, which means you can have several clusters and a job gets a unique ID on the cluster, and when a user submits a job, it's replicated on all the controllers of the cluster, and each tries to scale independently, and the first one that can wins basically. That's there are some constraints there. So every cluster needs to be able to accept the job, for example, is I think one of the constraints at the moment. So it's
In what way? What do you mean by needs to be able to accept?
so if one rejects a job for, I don't know, the queue is not there, all reject the job.
Yeah.
So this is the thing.
Is
Yeah.
it a feature enabled on the? Where, at what level is this enabled?
Sorry?
At what level is this enabled?
What do you?
Is this something that the users can choose, or is this something?
No, that's sysadmin side. So if you set up like 3 Slurm controllers and you federate them together, the job IDs get longer, and it's actually a pretty extensive patch. We do have a use case for that at NERSC because we have because Cray systems are super fun. You have an internal system, the mainframe, and I like saying mainframe, so I'm going to say it again. The mainframe, like it's 1972. The mainframe. Sorry. So the internal system, and then you have login nodes that are inside the mainframe. I said it again. And then you have e-login nodes. And an e-login node is a node that doesn't have access to the high-speed Aries network. So we want to federate basically a part of the e-login nodes with the scheduler running inside of the Cray. It would be an interesting experiment. SPANK plugins are basically prolog epilogue scripts on steroids, and it's you can code them in C, because Slurm is basically C all the way, or you can use Lua by a wrapper developed at Lawrence Livermore, I think. And there are a few.
Yeah, that was
There are a few plugins floating around. You can do X11 forwarding by specifying a parameter, and it's going to set up a tunnel back to the login node. You can do an out-of-memory notifying. That's the thing. We have a thing at NERSC called NERSC perf, and that star means that is going to. It should be open sourced as well. That loads Intel vTune before the job starts. So a user can request, I would like to have the vTune loaded, and it loads the kernel module for the user and unloads it again when he finishes running the job. So actually, our users like that quite a lot. Then there is a list of things that I found pretty cool that I stumbled over that are kind of smallish but make it really nice to use. There is strigger, which can fire events based on stuff that happens in your cluster, like a node going down, it calls a script and fires an event there. You can, if Slurm decides to drain a node, which usually happens if it cannot complete the job step, it puts them into drain. It can also fire an event. If a job completes, if a failover event happens, you can call a script and do whatever you like there. And that's, I think, I'm not sure if the users can do that as well. There is PAM Slurm adopt, which was mentioned before. So if you SSH into a login node, it's gonna take that SSH session and it's gonna put it in the C group that's running on that of the user that's running on the login node. On the compute node. If you have several jobs, it's configurable how it reacts if you do node sharing. I think you can pick one at random or put in the first one that was started there or something like this. SDiag is an interesting one, especially for the sysadmin community. SDiag shows you statistics of the scheduler, like pretty detailed, and how it does backfill, how long did backfill run the last time, how deep did it go, how many jobs have been backfilled, for example, and which is pretty handy, the rate of RPCs. So you see, because if you type sbatch, Slurm considers that an RPC, and you're going to see that in error messages sometimes. So you can see which users are basically stressing your controller the most. There is a super minor feature which can be pretty great for some use cases. In job arrays, you can say after core for corresponding. So if you have one array and the second array, then the first element in the second array starts running after the first element in the first array finished, and not the whole job array. So that can be quite handy for certain use cases. I guess I talk about that, but bioinformatics comes to mind. So for those workflows, that can be cool. What Slurm also can do is extensive debug logging. So especially when you procure a new system in the beginning, turn on this debug logging where the scheduler basically logs how it decides which jobs it schedules and that kind of stuff. There is only one thing that you need to take care of. If you log to disk, that's an interesting catch. If you log to disk, the log calls block, so they can basically drag down your scheduler. If you use syslog, that's not the case, because that's asynchronous, but when you log to disk, you need to be careful that your disk is actually fast enough, because otherwise you're gonna slow down your scheduler. Why I wrote Gordon Bell approved is an interesting point. I'm just gonna skip that. Yeah, there are, because I only mentioned the good features, which doesn't sound like me at all. I thought I'm gonna put a slide in there, the things to watch out for. So what we see is that basically Slurm displays, so if you have a user, Slurm is gonna give the user everything. It's gonna expose a whole lot of information that's maybe you don't want the user to see, and the user is going to start depending on that, so that's something to watch out for. It's not sure how to fix that problem, but another thing that I stumbled over is the error messages can be cryptic. Even for a sysadmin, sometimes you're like, what exactly does that mean? You're going to have a format like RPC failed permission denied. For example, a user is not going to read that error message. If the error message would be failed submitting to X, you don't have permission or something.
The user sees this message, or this is in the log for the system admins? Because
no, that sometimes
not that Dork is that much better than giving clear error messages.
Yeah,
No spec fail if you need anything.
Or maybe that's a general scheduler problem. That could be. And oh yeah, the logs I went over, and the last point is a super interesting one because that actually happened in production. If you start a Slurm controller, it's gonna kill the one that's running at the moment. So if you're on your controller node and you, for whatever reason, start Slurm, invoke Slurm CTLD, it's gonna kill your currently running controller. That's something to watch out for. And that was it from my part.
So how many plugins do you run in production?
How many?
Plugins.
Okay.
So Slurm. So I know that some people in the UK were testing Slurm for the throughput system, right? And they say Slurm is nice until you turn on the plugins.
I think you mean like how many jobs do we run?
How many plugins do you have configured, loaded in Slurm in production?
Sorry, I don't.
Plugins, not like,
How many plugins?
yeah.
Plugs.
What kind of plugins?
Just know which ones.
How
How many?
many? Because they're not part of the standard code base, right?
You said you also mentioned that all the nice things come via plugins.
Well, depends on. Internally in Slurm, everything's a plugin. The scheduler is a plugin. The FIFO and the priority stuff is a plugin. You mean like SPANK plugins?
No, I mean the scheduler.
I think we're quite happy nowadays with the scheduler. It took some tuning, and we do run a very. So the scheduler parameter line is like, I'm going to use a scientific term, approximately this long. So there is some tuning necessary, and the defaults are sometimes a bit counterintuitive. So it does scale. I'm not sure. You mean like if you have more jobs, like you submit a million jobs?
To configure it to get to the state that you want to run it, you have to enable lots of features via plugins, right? The question is how many, and does it and how many? Is it still stable when you enable more plugins or not?
Basically, everything I showed we use could be the and more. I think we also run some custom patches, but there I would need to ask what we actually do. Oh, that's another thing. If you run it, it's really nice to get support by Scalingly, because those guys are pretty amazing when it comes to supporting their stuff.
And for GPU support, it's really intelligent. If you have multiple GPUs in one node, you can easily split them up into several users.
Yes, it's gonna set NVIDIA visible devices, I think,
It
automatically.
doesn't go to C groups yet.
Oh, and it does C groups as well.
And does it record metrics about GPU usage too?
What metrics?
Yeah, what the load on your GPU and stuff like that.
I think
Lua records a whole bunch of metrics that can extract through the general NVIDIA interface of the card.
Not that I'm aware. I think it only tracks that you use the CPU over X amount of time. But I think that would be it, yeah. You could write a plugin. There are so left
already
this,
exists. I don't know.
there are job accounting plugins that you can hook into. I think so you can, for example, every time a job finishes, you can pull out a message to Elasticsearch and that build your database as you go. Or job profiling plugins would be, I think, the closest to that. You can measure like memory usage in real time. I think Carlos Fenoy has a few things on GitHub if you're interested in that.
This is a question from Andy, but there's a scheduling simulator in Slurm. Have you tried that at all to tune?
We usually simulate in production.
Users. This is something you can use to tune the scheduler and see how well it does. Give them certain scheduling workload.
I know that there is a simulator.
You haven't tried.
How well that works, I think there are several even. I think it's slow.
For the
Like for our
for
thing, I
the
think
solar stuff.
it was also with the Slurm simulator. Oh, no, sorry. Those were with the Flux simulator. Which is
Right.
a little more
The stuff you're
Slurm
developing
than-
yourself.
Yeah, you can use the Flux simulator if you're interested in that kind of stuff. I think it might be easier.
That's a good question. What is Flux?
Flux is the next generation resource manager that Livermore is developing to follow on to Slurm. So that's, I mean, Slurm will continue. Slurm is its own company now, but we wanted to try out some new things. So we have a group working with another resource manager.
But why didn't they just write a plugin for Slurm?
Because it's an architectural decision. So Flux, for example, lets you do hierarchical scheduling. So you can have your own scheduler inside of your provision with Flux and actually manage your own jobs with your own policies in there.
Live intro and all of it.
Yeah. So it's designed to be fully recursive.
Yeah.
And you can actually use Flux in the Slurm partition right now, if you want to. Flux does not have all the security that Slurm has at the moment, but you can use it as a single user.
It's just like through the scope tasks.
It manages resources more generally, it has a hierarchical resource model. We can talk about this stuff a little bit. But like, we wanted to have support for things like IO workstation, right, which is like our workstation. You can kind of do it, so.
Yeah.
And we wanted more scalability in some places. But it didn't have What's that?
Nothing left to use. It was no. But in a sense, not invented use is like